Hello, this is my sniper simulator that I made because I'm kind of sick of games doing it wrong. So I made my research and tried to do this, we can say, sniper simulator. It's in like early phase, but already has some nice features. First one is picture-in-picture scope, because some games they add like picture, black texture with only the scope you can see, so you can see outside of the scope. Some other games they zoom everything, they zoom the picture inside the scope and also outside, like they zoom the whole scene. That is wrong, because then you can see things in detail that you shouldn't see unless you fucking put your scope there and see through the scope. Yeah, so this is proper simulation, only the scope is zoomed. You can see it has little curvature also, like simulating the lens. I don't know if this one is real, but I made it like cool effect. I think it looks nice. But apart from that, you can zoom your reticle. This is a first focal plane scope. So the reticle zooms with the scales with the zoom level, and you can also adjust the reticle by clicks. Each click is 0.1. I actually modeled this scope by some real scope. I think it was called what it's called? It was called, yeah, Valiant Epic. Okay, so it has minimum zoom 5, maximum zoom 25. It's first focal plane, it's mil dot with clicks 0.1. Yeah, so you can also use shift for setting like fine and coarse. Like with shift it is like 10 times more, 10 clicks, and without shift it's 1 click. I also made it like, you know, the sweeping manner, like when you rotate by hand. It's some the first clicks are a little bit faster than the end ones. A little bit of detail, but it's nice. Okay, so you can move your reticle. It actually moves like this in real scope. If you watch some video, the reticle is moving. It's not that the scope is moving when you are adjusting knobs. It's not that the scope is moving. Actually, only the reticle inside is moving. So this is also properly simulated. The games usually keep crosshair in center, but it's not like that. You set a reticle, for example, here. If you want to shoot that point. The reticle is scaled correctly. You can measure targets with it. Each target I placed here is 1.8 meters tall. That means it's average human size. And if we know this dimension, we can calculate distance of the target just using the scope. So let's try it. This target is exactly 1, 2, 3 dots, which is 3 mils tall, okay, in my scope view. So if it's 1.8 meters tall, then I multiply by 1000, because mil is like milliradian. It is 1000 of the radian, so we multiply by 1000, we get 1800. And this value, basically 1800, we can skip this step. We can always remember 1800 divided by the amount of dots, amount of mils, which is 3. So 1800 divided by 3 is 600 exactly. So my target should be 600 meters away. I also made like the laser designator, which works at the center of the scope. That's why I put my reticle back, and I can verify. Yeah, 600 meters. Estimation was correct. Let's try to estimate this one. This one is, yeah, how to measure this. Basically, you must know other dimensions on the scope to estimate precisely. We can say, or we can see, it's almost 2 mils, yeah? But is it 1.7? Is it 1.8? Is it 1.9? That's the question. So how to know for sure, for better calculation? The diameter of the dot is 0.2 mils. Every dot is 0.2 mils in diameter across. So and the distance, like 2 mils that I mentioned, is from the center of the reticle to the center of the dot. Okay, so from the center of the dot we have the distance to the edge of the dot, which is half of the diameter. Diameter is 0.2, so radius half is 0.1. But we can see our target does not land on the bottom of the dot. There is little bit more space. So now we know it is less than 1.9, because 1.9 is exactly the bottom edge of the second dot. So we know it is less, and if we like look how much it is less, we can say half a dot. Okay, so that means another minus 0.1, and we should end up at, from original 2, we should end up at 1.8. Okay, and we have 1800 meters. Oh no, 18. Sorry. Yeah, 1.8 is target height in meters times 1000 is 1800 divided by 1.8, which is the mil size in our scope, is exactly 1000. Yeah, 1800 divided by 1.8 is exactly 1000, and we can verify. Okay, range the target, and it's 1000 meters. So let's check at the furthest target, and again we can say it's more than 1 mil, more than 1.1, because the end of the dot on top edge is still not enough, and we can say again like half of the dot is remaining to the top edge of the object. So this 1.2 mils. The 1 is for the center of the dot, 0.1 is for the edge of the dot, top edge, and 0.1 is like the remaining half dot space, so 1.2 mils. Okay, so 1800 divided by 1.2 is 1500. Okay, we can verify. R, yeah, 1500. So it is correct. So if you know these rules, you can estimate the target distance just using the scope. You don't need like laser designator, which is cool. It works for any object that you know dimension of. So if you know like the height of the target, or if you, for example, some, I don't know, windows are standard size on houses, door is usually standard size. Car wheels, you can look up, if you know the model of the car, you can look up the span of the tire. Yeah, you can basically use anything that you know dimension of to like estimate distance with this scope. But okay, let's get to shot. Actually, this is properly simulated. There is bullet drop, there is wind deflection, and there is bullet drift simulated. So we need to, if I like fire now, it will hit somewhere here because there is bullet drop, and we need to compensate for that. That's why we have these sniper tables that we can show and hide, and we know we are shooting at 1500 meters. So our table value of bullet drop for 1500 meters is 13.75. So let me set that. You can see that the scope is not enough to display because I was zoomed in. So I must zoom out. 13.70. Yeah, I can move like also 10 clicks. So yeah, we can say 13.8. There is no tailwind, headwind, so for elevation we are done. I actually set the wind speed to constant, 4 meters per second to right, so I don't have to like recalculate while I talk. So only for debug purpose I set it constant, otherwise the wind changes of course over time. Let's now estimate the crosswind. Okay, so the table value is for 1 meters per second. We have 4 meters per second, so we need to multiply our table value by 4. Yeah, it's also good like to try to calculate not precisely always, but simply. Yeah, so now I have to multiply 0.28 times 4. That is not easy for me, so I make it easy by multiplying 0.3 instead, because I know that 3 times 4 is 12, so it will be 1.2. Okay, but that's not precise. So can we make it more precise? Yeah. What was the missing part? Like 0.3 and 0.28. The difference is 0.02. If I multiply that by 4, which is our wind speed, I get 0.08, which is almost, if I run this, 0.1. So from my result, yeah, 1.2, I subtract 1, 0.1. Actually I should 0.8, but for simplification I do 0.1. So my correction will be 1.1. Okay, that's for crosswind. Now there is bullet drift on 1500 meters. It's already significant, quite, not much, but not zero. It's 0.2. Okay, so let's add 2 clicks more, and our final correction is 1.3 for the windage and bullet drift. Bullet drift is always to the right side because it drifts to the direction of the spin, which is due to rifle in the barrel. Okay, and it's always right. So basically, if the wind was blowing the left side, I would add like minus correction, but then I would add plus 0.2, and it would like cancel the correction. Now, because the wind is blowing to the right, it like extends the correction. Okay. Yeah, so now I need to zoom in, so I still see the reticle, kind of, and I'm ready to shoot. The bullet should impact like 2.2 seconds from the moment I fire it. Okay, so yeah, we landed on the target precisely. I can zoom out so you can see how far the target is, and what's the actual bullet path. You can also see a like dynamic recoil. It always like after shot it ends at different place. Like now it ended like left up. Now it ended almost same place. Now it ended like right bottom, and it is like shaking to simulate like the shooter is fighting the recoil. Yeah, I think I covered all the features that I made in this. Yeah, and I will try to extend this and maybe make another video about progress. Okay, if you made it to the end, thanks for watching, and that's all from me. See you.